In this video, we're continuing our discussion about measures of central tendency, and the example we have deals with the characteristics of a rock fall. In environmental geology, computer simulation was employed to estimate how far a block from a collapsing rock fall will bounce, and this is called rebound length down a soil slope. Based on the depth, location, and angle of block soil impact marks left on the slope of an actual rockfall, the following 13 rebound lengths in meters were estimated. The data are saved in the ROCKFALL file if you happen to have access to StatCrunch. Compute the mean, median, and mode of the rebound lengths and interpret these values. We are given the 13 measurements for the data, so to calculate the mean, we will add all of the measurements and divide by the number of measurements. So once we add, the total is 126.32, and then we will need to divide by the 13 measurements to end up with 9.716. So this number, 9.716, represents a block from a collapsing rockfall will bounce an average of 9.72 meters. So that's our interpretation of that number. The median is found by first arranging the measurements in order, and I chose to arrange them from the smallest to the largest. You can also arrange them from the largest to the smallest. So I have my list of measurements in order, and then you are making a series of elimination to find the center value. Since we do have an odd number of measurements, there will be just one measurement in the center. So as I'm eliminating, I would take the smallest value and eliminate the largest value. Then I work my way in. Another smallest value eliminated with the largest value, and so on until I get to the center, 10.94. So our interpretation of this number is the median bounce distance is 10.94 meters. Finally, the mode. The mode would represent the most frequently occurring measurement. There are no measurements repeating in this data set. Therefore, since none of the measurements are duplicated, no mode exists.